In this video, we want to look at systems of linear inequalities. So let me start by writing one up here, okay? So we've seen problems like this, y is greater than or equal to 2x plus 1. We have also seen problems like y is less than negative x plus 2. Either one of these is called a linear inequality. But now what we want to consider is the case where we want both of these things to be true, an AND case. So let's start by plotting the first inequality. Because it's greater than or equal to, we'll plot a solid line. You'll notice I'm starting at the y-intercept and quickly going up in a 2-to-1 ratio, and then I will go down in a 2-to-1 ratio in the other direction, and that will let me get a relatively straight freehand line going through the points. Now, we've talked about ways to get the solution for this, and we'll come back to those in just a few moments. When I look at the second inequality, the y-intercept is 1 unit higher, and I'm going down in a 1-to-1 ratio. So the slope of -1. So I can plot a bunch of points here. And then I can go up in the opposite direction. Okay, and now this one doesn't have an equality in there. It's simply less than. So this should be a dashed line. So I'm just going to put dashes in between my points and create a dashed line to work with. Okay, so now we have 2 lines instead of just one. When we had one line, we had 2 choices. We could either have the solution be in the region above the line or the region below the line. Now we have 4 regions. We'll call this region 1. Region 1 is above both lines. We have region 2 over on the right, but region 2 is really the region that is below the brown line and above the blue line. Then we have down here region 3. Region 3 is below both lines, and off to the left we have region 4, and region 4 is below the blue line but above the brown line. Now we have to satisfy both sets of equations. So the quick way of doing this is to just consider in case 1, we need y values that are greater than 2x plus 1. So that indicates that we need to be above the brown line. In the second case, we need y values that are less than 2x plus 1. So we need to be below the blue line. So just by a quick inspection, we can see we're above the brown line or below the blue line. Well, which region is above the brown line yet below the blue line? That would be region 4. Okay. Another way to do this is to test points. Okay. But when we test points, we want to use easy test points. Easy test points are ones where the arithmetic will be simple. So I think the easiest test point to use is 0, 0. Notice if I plot 0, 0, it's not on either line. You don't want to pick a test point that falls at the intersection of the lines or on either line. We need to find test points that are clearly in one of the 4 regions. Other easy test points would be things like 1, 1, or combinations of the first 2, things like that. There are no numbers to work with that are any easier than 0 and 1. I'm sort of biased towards 0, 0, so as long as the lines don't go through the origin, that's what I would test. So if I were to look at my Brown inequality, the first statement, I would have, if I use 0, 0, I would get 0 is greater than or equal to 2 times 0 plus 1, which means that 0 is greater than 1. Clearly a false statement. Since 0, 0 was below the brown line, that indicates that our real solution must be above the brown line. Continuing onward, if we look at the second equation and we substitute the same point, 0, 0, you could use a different point, but you might as well stick with what we've been doing. We would get 0 is less than the negative of 0 plus 2. 2 clearly is greater than 0, so this makes a very true statement. Since 0, 0 was in fact below the blue line, we would know that all points below the blue line are part of the solution. So we want the region that is above the brown line and below the blue line, and you can see that would be region 4. Okay, so the way we could indicate this as our answer is to shade in region 4. We could do something like this, and you can see that only region 4 satisfies both of the inequalities. So our solution is that. Notice the solution does not include the points on the blue line, but does include points on the brown line.